Hi, Math 30-2s. We're going to be finishing off logical reasoning and set theory today, lesson 5. So pretty short chapter, and today's lesson is actually also really short. So I will notify you on the Google Classroom in the next week or so about an upcoming test for this chapter. I'll give you a couple days to catch up with all the lessons, ask any questions via email, pictures that you can send in to me so I can make sure you understand this chapter before we test you on it. Okay, so just to start today, it does say here on the side, okay, that to be eligible to vote in Canada, a person must be, okay, a couple things here. It says 1, a Canadian citizen, 2, at least 18 years of age, and on a list of electors. So for this lesson, when we see the phrase Canadian citizen 18 years of age or older, we're going to know that the person's name is on the list of electors. Okay, so again, just something that we need to assume moving forward so that we can complete the questions that they are going to ask us. So the first thing we take a look at today is, obviously because it's bolded here, okay, an important term called conditional statements. So a conditional statement is a statement that is written using two words, okay, if and then. There's two parts to it. The what we call hypothesis, okay, so the part that follows the if, and then a conclusion, okay, the part that comes after the then. So when I take a look at a conditional statement, sometimes they call it an if-then proposition. It may be true or false. It doesn't necessarily have to be true. So for example, if, there's the if, okay, if a Canadian citizen is 18 years of age or older, then the person is able to vote. Okay, here's another one. If a person lives in Victoria, then the person must have been born in BC. Okay, so when we take a look at the first statement, if a Canadian citizen is 18 years of age or older, then the person is able to vote. Okay, that's true. So there's an example of an if-then proposition or a conditional statement that's true. The second one, the ones I circled in red, if a person lives in Victoria, then the person must have been born in BC. That's an example of an if-then proposition or a conditional statement that is false. So again, just bringing to light that when we deal with conditional statements, they may be true or they may be false. Okay, moving on to the next important term for today, which is called the converse. So a conditional statement has a converse, okay, which again may or may not be true. Okay, when we talk about the converse. So what is the converse? The converse is when the hypothesis and the conclusion are interchanged. So you switch those portions of the statement. So again, if I go back to the questions or the statements we just did, there's the if, there's the then, but the portions that follow, okay, are switched from the previous statements there. Okay, so I just interchanged those statements. So now, if a Canadian citizen is able to vote, then the person is 18 years of age or older. Again, in the second one, okay, I switched the portions. There's the if and the then, but I switched the portions that came after the if and then. So, if a person was born in BC, then the person must live in Victoria. Okay, again, first one true, the second one is false. Okay, so two important definitions already today, conditional statements and converse. Conditional statements just have an if and a then portion to their statements, may or may not be true. The converse is when we switch the if and then portions of our conditional statement, and again, the converse may or may not be true. So, write the following conditional statement as a conditional statement and identify the hypothesis and the conclusion. So an acute angled triangle has three angles that are each less than 190 degrees. So I want to write that as an if-then statement, okay, which is the same as saying a conditional statement. So it'll work like this. So if, okay, so there's the first word I need to have in there. If a triangle is acute angled, okay, so there's the first part of the statement, comma, then, so there's the then, the if then it has three angles that are each less than 90 degrees. Okay, so I've written it out as an if-then statement. So it says after that, also identify the hypothesis and the conclusion. So remember, the hypothesis comes after the if portion. So what I underlined in blue there is the hypothesis. Okay, comes after the if portion of the statement, and the conclusion comes after the then portion of the statement. So what I underlined in red there is what we determined to be the conclusion. Okay, so it says write the converse of the conditional statement. Is the converse true? So if I'm going to write the converse, again, I'm going to have if and then in my statement, but I switch. So now it's if a triangle, so there's the if a triangle has 3 angles that are each less than 90 degrees, okay, then, so there's the then portion of the statement, then it is acute angled. Okay, so I've written down what we call the converse. This time, I switched the conclusion and hypothesis from the original statement. So there is now what was the conclusion from the original statement, and the hypothesis from the original statement now comes second after the then statement. So they now say, is that true or is that false? Okay, so this is true. All right, so if I do have a triangle with 3 angles that are each less than 90 degrees, I do have what is called an acute angle triangle. Write down a conditional statement, a true conditional statement, for which the converse is not true. So I want an original statement that's true, where when I switch the if-then portions of the statement, it is not true. So here's one example. Obviously, there are infinite examples that do exist, but I'll say if, okay, there's the if portion, if a number is divisible by 4, then, okay, then it is an even number. Okay, so when you take a look at all the numbers that are divisible by 4, they are even numbers. So that is a conditional statement that is true. Okay, but if I switch the if and then portions of the statement, so that would read, if a number is even, then it's divisible by 4. Okay, that's not true. So something like 10, right? So the statement I wrote, the conditional statement I wrote is true. If I were to switch the if and then portions of that statement, it would not be true. So therefore, the converse is not true. All right, so next page, next important term. Biconditional statements. So when we talk about something that is defined as a biconditional statement, it says in which the statement and its converse are both true. So if I have a conditional statement, it's true. I switch the if and then portions of the statement and it's still true. It is what we have known as a biconditional statement. I can then say and write that statement as an if and only if statement. Okay, so for example, a Canadian citizen is allowed to vote if and only if the person is at least 18 years of old. So that goes back to our examples on the first page where I had the 2 conditional statements in the first 2 examples and they were both true. I can then write that as a biconditional statement, saying if and only if in that statement. So for example, here it reads that a conditional statement and its converse are given. So here's the conditional statement. If a triangle is obtuse angled, then the triangle has one angle between 90 degrees and 80 degrees. Then we take a look at the converse. Okay, if a triangle has one angle between 90 degrees and 180 degrees, then the triangle is obtuse angled. If both statements are true, write a biconditional statement. Well, both statements are true, so I can write this as a biconditional statement. Now, when I do that, I have to use the phrase if and only if. So it'll look like this. A triangle is obtuse angled okay, and here's the phrase we're going to use. If and only if. Okay, if and only if it has one angle between 90 degrees and 180 degrees. Okay, and there you go. So because the original statement was true and the converse is true, I can write them as one combined statement using the phrase if and only if. Okay, next term, contrapositive. So like I said, there's lots of terms today. Contrapositive of a conditional statement is formed by taking the converse and negating both the hypothesis and the conclusion. Okay, so you start with a conditional statement, write the converse, and then negate both of them, which basically means make both of them negative. So here's an example they walk us through. Okay, they take a conditional statement. Okay, in step 1, if a citizen is 18 years of age or older, then the person is able to vote. Then they write the converse. Okay, they switch the if and then portions of the statement. So now it reads, if a Canadian citizen is able to vote, then the person is 18 years of age or older. The contrapositive is I take the converse and make both parts negative. So if a Canadian citizen is not able to vote, then the person is not 18 years of age or older. Okay, so start with the conditional statement, write the converse, switch the if and then portions, and then negate both of those portions, and you have what's called the contrapositive. So write the converse and the contrapositive of the following conditional statement. So they give us the conditional statement to start with. So if a triangle is obtuse angled, then the triangle has one angle between 90 degrees and 180. So the converse is switching the if and then portions. So the converse would look like this. If a triangle has one angle, so if a triangle has one angle between 90 degrees and 180 degrees, then the triangle is obtuse angled. Okay, so there's kind of step 1. I've written what we call the converse. Now, when I go and write the contrapositive, I negate both portions of the converse statement. So it's going to look exactly the same as the converse, but it'll look like this. If a triangle, now in the converse it said has one angle between 90 and 180 degrees. So now I'm going to say if a triangle does not have one angle between 90 degrees and 180 degrees, then the triangle, okay, now I negate it, is not obtuse angled. Okay, so again, I just negated both portions of the converse statement, and that gives me what we call the contrapositive. Okay, so let's work on some examples now. The definitions for today are kind of done. For the most part, now we apply them, okay? So it says, consider the following if-then proposition. So again, remember an if-then proposition, okay, same as kind of a conditional statement. So it's saying if z, and again, remember this means is greater than, so if z is greater than 2, then z squared is going to be greater than 4. So is that original proposition true? Meaning if z is bigger than 2, is z squared going to be bigger than 4? Yes, okay, that is true. If I take any number that's bigger than 2 and I square it, it will be bigger than 4. Now, after that, it says, if not, give a counterexample. A counterexample is an example that proves something is not true. So if I were to say no, then I have to provide what's called a counterexample to show that it's not true, okay? Now, it says, write the converse, is it true? So here's the converse, right? The converse is you switch the if and then portion. So it would be if z squared is bigger than 4, then z is going to be bigger than 2, okay? Now, is this true? Okay, well, this is not true, okay? Oops. So this is not true. So it says I have to provide a counterexample, okay? So remember when basically the counterexample here comes from me squaring a negative number. Remember when I square a negative number, it's positive. So for example, let's say I take a z value that's equal to -4, okay? So z equaling -4 is a counterexample. Okay, why? Well, because -3, okay, is not bigger than 2, but -3 squared is 9, okay, which is bigger than 4, isn't it? So I did take a value that ends up being bigger when I square it than 4, but the actual value of z itself was not bigger than 2, okay? So if I take a negative number, which is smaller than 2, okay, and I square it, I actually still get a number that's bigger than 4. So, okay, there's a counterexample proving that it's not true. Write the contrapositive, okay? So the contrapositive would be taking the converse and negating both portions. So it would be if z squared is not bigger than 4, so that's how we write is not bigger, then we would say z is not bigger than 2, okay? And again, is this true? So if I square something and it's not bigger than 4, then that number is not bigger than 2. Okay, this is true. Okay, this is true. So I do not need to provide a counterexample because I'm not trying to disprove it. Okay, it is true. All right, next. Consider the following conditional statement. If Peter lives in Saskatchewan, then Peter lives in Regina. Is this conditional statement true? So if Peter lives in Saskatchewan, he lives in Regina. Is this true? No, it's not true. Peter, right, could live in a different town or city in Saskatchewan, right? Peter could live anywhere in Saskatchewan, okay? He doesn't have to live in Regina, okay? So there's A. Write the converse. Is it true? So converse again, switch the if and then portions of the statement. So if Peter lives in Regina, then Peter lives in Saskatchewan. All right, so there's the converse. Is this true? If Peter lives in Regina, then he lives in Saskatchewan. Okay, this is true, obviously, since Regina is in Saskatchewan. Okay, C, write the contrapositive. Is it true? So again, contrapositive is taking the converse and negating it. So if Peter does not live in Regina, then Peter does not live in Saskatchewan. All right, so if Peter doesn't live in Regina, then Peter does not live in Saskatchewan. Okay, that's not true, right? That's obviously false because, again, he could live in Saskatoon. He could live anywhere in Saskatchewan, okay? Or in Saskatchewan, but basically, okay, that is a false statement, okay? So Saskatoon, he could live there, but that's still in Saskatchewan, all right? So what's important from the following, okay, whether you noticed it or not as we move through those lessons, okay, are the following key points. It says a conditional statement and its contrapositive are equivalent statements, okay? This means that if a conditional statement is true, then so will the contrapositive be true. If a conditional statement is false, then so will the contrapositive. So whatever a conditional statement, the original if-then proposition is, the contrapositive will follow, okay, whether that being true or false. Okay, so that's it for today's lesson. Like I said, pretty short, lots of definitions. You'll apply them to the examples they give, and that's the end of this chapter. So like I said, I'll give you a couple days to catch up on some work. Make sure you're understanding the material. I will post very soon when your next evaluation and test is. Hope you guys are doing well. Forward any questions, concerns to me, and I will get back to you. All right, talk to you guys soon. Bye.